Drabas, and he is, did you change your topic? No, okay. From prototype to deployment, increasing productivity and simplify the data operations in Python. And then I'm gonna just give you a quick little about him. Tom is a field engineer / solution architect with Voltron Data, and he has almost 20 years of experience, I'm gonna say 2 decades, working with data across multiple industries, ranging from airlines, finance and banking, and high tech. He has a PhD in operations research from the University of New South Wales, and he's also an author. And if you would like additional details, his bio gives a lot more information, but I'll turn it over. Please give a warm round of applause.
Thanks, everyone. I don't know, can you guys hear me fine? Awesome. Okay. Well, welcome to the last talk of the day. You've survived 3 days, and this is actually initially, when I heard that I'm going to be talking about 3 p.m. on Friday afternoon, I was kind of like, yeah, probably not a good time. But it actually sets the scene well for the rest of the talk. So if you're here, I'm hoping that you might enjoy what I have for you. So what we're going to talk about today is I will tell you a little bit about myself, right? So I worked as a data scientist, actually, here at Microsoft. So I'm going to give you a brief preview of what I've been dealing with in the past. We're going to look at what's wrong with the picture that I'm going to paint for you and look at some solutions that, the current technology that we at Voltron Data support. So very, very briefly, thank you for the introduction. I am a field engineer / solutions architect working for Voltron Data. I've worked in the past for Blazing SQL and Microsoft, so I'm actually on a familiar turf. I've spent about 5 years at Microsoft, and I want to say I probably spoke in about every single auditorium in this building in the past. I like data. So I wouldn't be a data scientist if I didn't like data, and I like them in any shape or form. It can be images. I've worked with images. I've worked with text data. So I'm always excited about what I can do with the data itself. If you want to connect with me, my LinkedIn profile is over there. Feel free to send me an invite. Now, as I said, I'm going to give you a little bit of a preview of what my life looked in the past as a data scientist. And yes, it's normally happened on Friday afternoon. My boss would show up at my desk and said, okay, well, Tuesday morning, we need to know what that little button over there is who's going to click on it with some level of confidence. So I need you to create a model to predict who's going to click on it and, yeah, chop, chop. So that's my Friday afternoon. If you, like me, you probably say, okay. And then you spend the whole, evening on Friday to get some data, load it up on your computer, work on the model over the weekend, and 4 a.m. on Monday morning, you say, okay, well, I finally have something that works. So I've built my beautiful ML model, and now I need to get it into production, right? So I go to 8 a.m. On Monday morning. I set up a meeting with my deployment team. And I'm really, really trying to not fall asleep, first of all, and then try to convince them that, okay, I have this model. I have this data. I need you to take it and score all of these people because we need to know the company's future depends on it. And they look at it and they say, yeah, probably not going to work because this is not, you wrote it in what? Like pandas? Who understands pandas? We work in COBOL for the, yeah. So when you hear this, it cannot be done. You kind of flip out, and then you say, well, they tell you they need to take all of this code, learn pandas, first of all, understand what you've done, and then they need to rewrite the whole thing, right? They need to take all of these transformations you've done to your data and featureize your data, and whatever you've done there, rewrite the whole thing to run in the production system. And at the end of the day, it feels better. It feels like you could have just used a calculator to score every single person in that particular database that you need to score, and it will be easier to use the calculator because it will be probably faster. They tell you that it's going to take 5 weeks for a whole team of people to do this. So ultimately, at the end of the day, your beautiful GPT-4 model that you've worked so hard over the weekend, spent countless hours training and messaging, gets reduced to be a logistic regression because that's what the final production level and system supports. Full disclosure, I have no grudges against logistic regressions. I know they work. It's just, at the end of the day, you work hard and you want, the model to be the best. So what's wrong with that picture, right? There's multiple friction points in this whole process. And I would like to say and make an argument that there is a mismatch in tooling, right? You've worked on something on your local machine or even on, some dev, system in your team. And when it comes down to productionizing that code, there is a mismatch, right? So first of all, you need to translate that code. You need to take all of those transformations that you've worked so hard, and somebody else needs to read that and convert it. So going from Python, from Pandas to Spark or Snowflake, it's a lengthy process. Somebody needs to do it. It's error prone, and especially if the person that is not familiar with with the system that you've worked on, it can be quite expensive. The production system might not have all the functionality that you would like to use. So it might not have all the transformations that you've used and applied to your data. It might not have all the features that you require. So you need to hack it or go without that functionality. And also, at the very beginning of your project, you might have sampled the data, but the sampling might have been not representative of the whole general population. You forgot to include one of the distributions, and the model that you eventually estimate in the production doesn't perform as well as the stuff that you've developed over the weekend. So the mismatch in tooling ultimately leads to a very inefficient process, inefficient and error prone, and it costs money upfront without really guaranteeing any results. So a typical path that I already walked you through starts with me or you guys as a data scientist, where you get some data source from your systems. You go through the ingestion process. So let's say in Pandas you read a CSV or read Parquet, or somehow load that data into memory on your local machine. You do the data cleanup, so you remove all the outliers and handle nulls and, God forbid, play with the dates on your local machine. And eventually you are at the point where you can start playing with some featureization. You can apply logarithms, you can combine, concatenate strings, remove some words from the text and whatnot. And you build your model. So along this path, right now we're moving from left to right, but if the machine learning model or any model doesn't work, well, we go back. We go back because our features didn't work and they don't have enough predicting power. We forgot to remove some nulls, some columns that still have nulls, or there's a problem with the data ingestion and it only read 1,000 rows versus the whole file, or actually we realize that this is the wrong file that we've been reading. So we go all the way back. It can go either way. But let's assume we've done all of this and we have we've trained a machine learning model. We output some code. The code will be explaining what we've done to the data and how we want the model to be trained. So what do we do next? Well, we go to the deployment team. And the ML ops team takes that file, takes that code, looks at it, and then needs to rewrite it, right? So it will need to replicate, okay, my big data sits in this particular cluster, so I need to point it to a different place. I need to read it in a format that my production system understands. Apply the same cleanup, methodology that you had in the prototype. Apply the same data transformations, and train the model. What happens if the model doesn't work? Well, if the model doesn't work, we go back to the drawing board. So it goes back to the data scientist to, okay, well, it doesn't work. What do you want me to do? and the cycle repeats, right? So the data scientist goes through its own paces, tries again, goes back. We need to, the MLOps needs to reapply the new transformations, rewrite the code, and ultimately, finally, we can go to the model deployment and monitoring. Now, at the end of the day, if something, along the way, the model performance drifts, we go back to the square one, and we need to go back to the data scientist. So this is, as you can see, this is a very, very slowly moving process. And the cost of that process is quite real. It quickly adds up. So we have the development cost, right? We need to translate that code, and it costs money. It costs money, on the data science side, and it also costs money to translate that code to run in the production time. It's, we pay a lot of money for the dev time. This also applies to the missed opportunity cost, right? So it takes time to deploy that model. The process is quite slow. So at the end, once the model is deployed, that opportunity might not exist in the market. And there's also a productivity cost, right? Instead of making the model perform better, we spend time translating and rewriting the code in order to make it run in the production. So eventually, it might be really chopping into any company's bottom line. So what can we do about it? Have you guys seen, there's two guys from Voltron Data. They had a talk yesterday about IBIS. Any show of hands who was here? No? OK, good. IBIS. IBIS is a new framework written in Python. So you can write a very, very high-level Python code to understand the transformations. And it's very easy to see what's going on. We read movies, we group by year, and apply mean to the average rating column. So everything is right there, right on at your fingertips. It starts actually the way I like it. It starts with the data source. So if you're familiar with SQL, it's like, OK, select these columns from this table. Here I know that I go to movies, and I don't need to scroll down through 100 lines of code that list all the columns that I want in SQL. I know that I go to movies. If SQL is your thing, IBIS can compile to SQL as well. So the same thing that we did over here, it can compile to SQL and run on any backend that IBIS supports. And there's multiple backends that that support SQL. And some of them are listed here. I know for a fact that actually another one was added yesterday, but I don't yet know which one. But you can see that you can run things in pandas. So if you want to, you can still use the code you've had it before. It runs on Dask, PySpark, Snowflake. Of course, the different backends, they don't have all the functionality. And if you go to that link over there, there's a support matrix that tells you that, OK, this particular backend supports this particular operation on dates, or this particular operation on text. This list is long. It's, I think, if I remember right, 15. If we include the latest one, it's going to be 16. And it keeps growing. And there's going to be more coming in. Now, why does that matter? Because the standards make everyone's lives much easier. So if we go back to that original process that I described at the very beginning, we have some data that sits somewhere, and we work with every single one of this on our local machine or in the production. We need to do some data preparation. So if we use IBIS, we can prototype on our local machine, on my laptop, running pandas or DuckDB, or if I really want to test things how they work in PySpark, I can run a local PySpark single node, and then build my model. Onyx is another standardized form of explaining and describing how different machine learning models score the data. And then when you hand over these two files to your deployment team, it's much easier for them to run with IBIS and run with Onyx in order to actually shorten that time to to productionizing to deployment of your model. And as I said, the same expressions actually work in any backend. So in this particular case, we are using Pandas to connect and read some New York Taxi trip data. So this is New York Taxi data set, single month in Parquet. We're using PyArrow. If you don't use PyArrow when you're reading your data stored in Parquet in Pandas, I highly recommend that. I think it defaults right now to read to use PyArrow engine. And then we apply some cleanup. So we remove some fares that were below 0 because you cannot really be paid to run the cab, and everything that was above $500 is probably a little bit excessive. If the taxi didn't carry any passengers or more than 6, we probably don't want to look at those data because they seem to be outliers. And if you've ever worked with the New York Taxi data sets, you know that there are some Latin logs for pickup and drop-off that are in the middle of the Atlantic Ocean. So we probably don't want to include those if we want to build a meaningful machine learning model. And then, if you're familiar with Pandas, the syntax is kind of similar. It's not one for one, but it's kind of similar. And it's easy to memorize that. Filter, we pass the list of all the query fragments, and at the end of the day, we count how many records we have once we've cleaned up our data set. So in this case, a little bit shy of 13.5 million records. Now this is Pandas. This is DuckDB. So I've changed the top 2 lines to, instead of going to Pandas backend engine, to instantiate a DuckDB database in memory with 8 threads and 12 gigabytes of memory limit. I'm reading exactly the same data set. I haven't changed a thing in the rest of the code. And it produces exactly the same result. So that's the beauty of, I don't need to rewrite it. I don't need to take my Pandas code to clean up my data, rewrite it in SQL to run it in DuckDB. I can use IBIS, and it's going to do that for me. But it can do more, right? So it can work across the aisle. What it means that I can create some data sets in one backend. In this particular case, I'm using a Pandas data frame to normalize some of the payment types. And I can register the same data set in DuckDB with IBIS and use it to left join it to my original table to normalize my payment types. So I don't need to create a new table in DuckDB by saying, OK, create table with these types and then insert into these values. I can just quickly and very, very nicely create a small Pandas data frame that does that for me, and I register that as a table with DuckDB. Now, I can also use and work with data that are sitting remotely on some production systems. I can use Snowflake, register that Snowflake table, the batting table, directly from Snowflake, and use that in my local DuckDB instance to process that data. In this particular case, we try to find, what is the average for in any particular year from the batting table. And you can also work remotely. So you can write your normal, Python code and remotely run it on Snowflake. So in this particular case, we want to count how many vowels there is in the player ID. So we create a small Python UDF that checks for A, E, I, O, U, and Y, if we choose to include Y, counts how many of those occurrences we find in the player ID, and then eventually we count how many records there are with 1, 5, 4, 3, 2, or 0 vowels in the player ID. So going to IBIS and using IBIS to do all the data messaging before you actually try to build a machine learning model helps you to prove yourself that when you go to productionize that code, you only hand it over to production team, and you can run it on PySpark or any any supported production system that and it makes that process that much easier. But there's more. Recently, we started working. We as a Voltron Data, we believe in open source frameworks. So IBIS is one of them. We also have a vested interest in Substrate. Substrate is this new universal data expression language that allows you to express data operations in a very, very standardized way. And it is a cross-language specification. So as long as there exists a tool that allows you to take your data operations, no matter whether you come from Python, R, C++, Java, and Rust, as long as there is a substrate producer that allows you to convert those operations from either of these languages to a standardized format, you can run it on any engine that supports reading substrate data. It's a standardized way. So it declares the common operations, and you can also inject some custom operations to convert your data and transform them. But the main thing is that it decouples the front end, the way you write your code from where it executes. So you can write your code in Python, you can write your code in R, and the code in R, it produces substrate, and let's say pandas could understand and understand substrate and consume it. You could theoretically write code in R and execute that on pandas. So it is kind of like a Lego for a data ecosystem. You can write the code in any language you want or in any framework you want on the left-hand side, and as long as it produces a valid substrate plan, you can execute it on an Arrow native engine or SQL engine or a GPU engine. And it's interchangeable. Right? So if at any point in time you decide, okay, I've written my code in dplyr and R, and I tested that on my local machine running pandas or Arrow native engine, but now I want to deploy that on this beefy GPU cluster that I have sitting in a production, you just hand it over, and in theory, that's how this should work. So ultimately, the standards make everyone's life even easier. So if we use IBIS, and IBIS is already one of the main, one of the first substrate producers, you can technically even further, decouple and make this simpler for anyone to work with your data and deploy your machine learning models and take it from, inception, from the prototype to production. That's it. That was the last slide that I had for for this talk. I know it's it's late, and that's why I wanted to try to keep it a little bit shorter. But if you guys have any questions, I would be happy to answer them.
Any questions? I got one. Okay. Thank you.
You made some reference on an early slide about serializing models as ONNX. I'm wondering if there's any interplay between IBIS and ONNX, or if you have other recommendations on how to get models into ONNX.
So there's, not to my understanding. So IBIS works with the mostly on the ML preprocessing side. So if you need to featureize your data, if you need to clean it up and prepare it for modeling, that's how you normally do it. And after that, I would assume that if you use scikit-learn, or if you use PySpark MLlib, or any other machine learning model like TensorFlow or deep learning, it would be on their side for them to produce the ONNX file that can be then consumed in the production.
Any other questions? All right, let's give Tom a round of applause. Thank you.
Thank you.